We're talking about 800 horsepower and 1,250 newton meters from one e-motor.
Elon Musk was completely unprepared. In 2025, Koenigsegg unleashed an engine so potent, so next generation, it left Tesla reeling and Elon appearing stunned on live television. No hype, no press tour, just raw engineering dominance. A hybrid, boasting 2,300 horsepower, an e-motor that fits in a duffel bag, a synthetic fuel that makes gasoline look primitive. Is this the downfall of the electric vehicle era, or the moment it gets profoundly redefined? What Koenigsegg just accomplished will reshape the automotive landscape forever. And no one saw it coming. Let's dive in. How we got here. The EV dream. That overpromised. Something is fundamentally flawed in the electric revolution, and it's the industry's unspoken secret. Electric cars were meant to be our saviors, destined to eliminate the internal combustion engine and transform mobility. Instead, we have vehicles heavier than some commercial trucks, batteries that rely on strip mined, rare metals, and a driving dynamic that feels more like operating a smartphone than commanding a machine. So, where did it go wrong? Why is the EV hype machine starting to sputter? And what did Koenigsegg create that could send Elon Musk into a panic? It all began with a bold promise. When Tesla unveiled the original Roadster, it was more than a car. It was a gauntlet thrown down. Electric could be thrilling, silent, and desirable. Elon Musk wasn't merely selling cars. He was re-architecting an industry with over-the-air software, a proprietary charging network, and audacious claims that made legacy car makers seem like dinosaurs. Tesla's ascent was meteoric. The Model S redefined sedan performance. The Model 3 brought EVs to the masses. The Model X ventured into luxury SUVs. And the Cybertruck, love it or hate it, was impossible to ignore. Fueling Tesla's rise was a global paradigm shift. Governments were all in. Europe declared a continent-wide ban on internal combustion engines by 2035. California followed with its own aggressive phase-out plan. China, the world's largest auto market, poured resources into its domestic EV industry with massive subsidies. Cities began banning diesel cars. Automakers scrambled. General Motors pledged an all-electric lineup by 2035. Ford, Mercedes, and Volvo all announced ambitious timelines, but beneath the optimistic headlines, the reality was far messier. Let's talk about range anxiety. For all the talk, most EVs still can't match a full tank of gas, especially when you factor in real-world conditions like highway speeds or using the climate control. Cold climates, your battery capacity plummets. Fast charging is a solution, but it still means a 20 to 30-minute stop to reach 80% capacity. If you can find a working, unoccupied station, then there's the battery itself. A single Tesla Model S battery requires about 63 kilograms of lithium, along with cobalt, nickel, and other materials often sourced through destructive, polluting, or exploitative mining. Reports have tied cobalt mining to child labor. Lithium. Extraction is incredibly water-intensive, devastating local ecosystems. And those batteries are incredibly heavy. The average EV weighs hundreds of kilograms more than its gasoline counterpart. This extra weight wears out tires faster, stresses road infrastructure, and strains braking systems. Combine that with the poor recyclability of current-generation batteries, and the green halo starts to dim. But the most overlooked problem might be the soul. Despite their neck-snapping torque and silent operation, many EVs feel disconcertingly similar. They are smooth, quick, quiet, and ultimately forgettable. The driving experience has been digitized, dampened, and disconnected. There's no engine, roar, no satisfying gear change, no mechanical symphony. For driving purists, that essential thrill is gone. It's why critics have started calling them digital appliances on wheels. Even the would-be Tesla killers have followed the same script. Rimac Hyper EVs are astonishingly fast, but are monstrously heavy and complex. Lucid sedans are tech-forward, but face challenges with manufacturing scale. The Porsche Taycan is a precision instrument, yes, but it's still hampered by its massive battery pack. Everyone is working from the same blueprint. Bigger battery, more range, better UI. Different name, same concept. And this is exactly where Koenigsegg shatters the mold. This is not a company chasing sales volume. Koenigsegg is singularly obsessed with innovation, the kind that ignores trends and forges its own path. While the automotive world was trying to Xerox Tesla's homework, Koenigsegg was writing a new textbook in silence. For years, they worked from a small facility in Ängelholm, Sweden, building hypercars that seemed to defy the laws of physics. The Agera RS didn't just break speed records, it obliterated them. The Regera eliminated the gearbox entirely. The Jesko redefined what a track car could be, but nobody was prepared for what they did next. A 4-seat hybrid that could dust a Bugatti, powered by a motor so dense and powerful, it could fundamentally alter the future of electric propulsion. That motor, and the engine it's mated to, is why Elon Musk finally has a reason to be worried. The moment everything changed. Koenigsegg's shock and awe reveal in 2025, Koenigsegg did the unthinkable. No flashy press conference, no drawn-out teaser campaign, just a cold, clinical, world-altering announcement that left engineers speechless and competitors in disarray. In a single stroke, Christian von Koenigsegg revealed two innovations so far ahead of the curve, they made Tesla's powertrain strategy look dated. A synthetic-fueled combustion engine that runs cleaner than gas, and an electric motor so small, potent, and efficient, it made the industry's more batteries approach seem utterly primitive. The world took notice. Elon Musk was silent. So, what exactly did Koenigsegg do? First, the dark matter motor. That's Koenigsegg's name for its new in-house e-motor, and it perfectly describes it. Dense, mysterious, and unlike anything else out there. This motor weighs under 40 kilograms, less than a checked bag at the airport. Yet, it produces a staggering 800 horsepower and 1,250 newton-meters of torque. To put that in perspective, Tesla's Model S Plaid needs two larger, heavier motors to approach that level of torque. Koenigsegg did it with one. And it's not just the output, it's the science. The dark matter motor uses a axial flux design, a novel hybrid of radial and axial flux technologies. Radial flux is the standard in most EVs, proven and reliable. Axial flux motors are famous for their power density, but are notoriously difficult to manufacture at scale. Koenigsegg fused the best of both into a 6-phase architecture. This allows for smoother power delivery, superior heat management, and consistent peak performance. How small is it? Christian von Koenigsegg held it up during the reveal. It's roughly the size of a duffel bag, yet it churns out more torque than most heavy-duty trucks. And unlike multi-motor systems that require complex software for torque vectoring, the dark matter motor simplifies the whole process. It's a single, responsive unit connected to Koenigsegg's own custom inverter and torque converter. Fewer components, less weight, and zero wasted energy. The implications are enormous. It proves EVs don't have to be heavy to be powerful. You might ask, if the e-motor is that good, why bother with a combustion engine? Because the second part of Koenigsegg's reveal is just as revolutionary. A new quad-turbocharged engine that runs on synthetic e-fuel generates nearly 1,500 horsepower and produces close to zero net emissions. This isn't a recycled V8. It's a brand new engine designed from the ground up to burn clean and integrate with hybrid technology. Synthetic e-fuel is made by combining captured CO2 with hydrogen. When burned, it releases the same carbon that was captured to create it, making it essentially carbon neutral. Porsche is exploring these fuels, but Koenigsegg has built an engine born to run on them. When paired with the dark matter motor, the combined system generates an astounding 2,300 horsepower and 2,750 newton-meters of torque. These are not theoretical figures. This is the production spec for the updated Gemera, a 4-seat grand tourer with cup holders and luggage space that can out-accelerate a Bugatti Chiron. It does so without a massive, heavy battery, eliminating range anxiety and long charging stops. This alone would have been revolutionary. But what truly floored the industry was Koenigsegg's stealth approach. No marketing blitz. They just updated the Gemera's spec sheet and let the engineering speak for itself. The moment the technical details leaked, the industry buzz was deafening. What makes Koenigsegg different? Engineering no one can replicate? Koenigsegg doesn't just build cars. It engineers a different way of thinking. This is their true secret. The company designs machines free from the constraints that hobble its competitors. No legacy platforms, no supply chain compromises. If they can control a part, they build it themselves. This is why no one, not Tesla, not Ferrari, can simply copy what they do. Take their free valve technology. Most engines use camshafts to open and close valves. It's a centuries-old limiting technology. Koenigsegg threw it out, replacing it with pneumatic and electronic actuators that control each valve individually. The engine can switch from maximum power to extreme efficiency in an instant. This means fewer moving parts, less friction, and more power. While major automakers are still toying with variable valve timing, Koenigsegg has had this in production cars for years. Then there's the Regeera's direct drive. A normal car has a heavy, complex gearbox. Koenigsegg's solution? Get rid of it. The Regeera connects the engine to the wheels via a hydraulic coupling, supplemented by electric motors. The result is seamless, uninterrupted acceleration with fewer components. It's a concept so radical, most engineers deemed it impossible for a road car. Koenigsegg made it a reality. Their latest innovation is the Lightspeed transmission, LST. High-performance dual-clutch transmissions are fast but heavy. The LST uses a brilliant multi-clutch system that allows for instantaneous shifts between any gear. For example, from 8th to 3rd without passing through the gears in between. It's lighter and faster than a conventional DCT. This philosophy of in-house perfection extends everywhere. They weave their own carbon fiber to control its strength and weight. They 3D print their own titanium exhaust components. Every decision is made to improve performance. This is why Tesla cannot do what Koenigsegg does. Tesla is a mass-market manufacturer focused on scale and cost per unit. Their innovation is in software and production efficiency. Koenigsegg's goal isn't scale. It's pushing the absolute limits of automotive engineering. This brings us back to the dark matter motor. Koenigsegg's engineers saw the state of EV tech and asked, why use multiple motors when one designed correctly can do more? They broke from the industry-standard 3-phase motor with their 6-phase Raxial flux design, achieving superior torque density with less heat. And because the motor is paired with their new synthetic fuel V8, it enhances the visceral thrill of driving rather than erasing it. This engine isn't about looking backward, it's about proving combustion can have a clean, exciting future. Together, these technologies create a system that challenges the core assumptions of the EV movement. Do cars need to be heavy? Do we have to accept dull driving dynamics? Koenigsegg's answer is a resounding no. There is another way, one that blends the best of both worlds without the drawbacks. And if a small Swedish firm can achieve this, what does that say about the industry giants? What happens now? A fork in the road. The auto industry is now looking at Koenigsegg with a mixture of awe and fear. Because if Koenigsegg's approach, a compact, powerful e-motor paired with a lightweight, low-emission synthetic fuel engine, proves superior in real-world use, then the entire big battery EV model begins to look obsolete and clumsy. The industry's dirty little secret is that EVs are not as clean as advertised. Battery production requires mining that scars the earth and often involves unethical labor. Manufacturing and recycling them is energy-intensive. Synthetic fuels, however, offer a carbon-neutral alternative. They reuse carbon already in the atmosphere. The EU is already considering exemptions for synthetic fuels in its 2035 combustion ban. Koenigsegg is not just betting on this future. They have built the ultimate powertrain for it. Can anyone else catch up? It's unlikely. Koenigsegg's innovations are a product of their unique, vertically integrated structure. Major automakers like Ford or GM have invested billions in their battery platforms and supply chains. They can't simply pivot overnight. Koenigsegg will have a multi-year head start, not in patents, but in the know-how to make these complex systems work in harmony. Meanwhile, a new generation of buyers wants more than just silent transport. They want an experience, a machine that feels alive. Koenigsegg's reveal wasn't just about specs, it was a philosophical statement. A hybrid that is integrated from the ground up, not pieced together. A powertrain that delivers raw, visceral pleasure. Tesla now faces a critical dilemma. Elon Musk's all-in bet on batteries looked invincible, but if Koenigsegg's hybrid formula proves viable, Tesla's roadmap could look surprisingly one-dimensional. After the announcement, Musk posted a cryptic tweet: "Physics is the ultimate arbiter." Supporters saw defiance, critics saw deflection. Behind the scenes, Tesla engineers were reportedly forced into a difficult conversation. How did a boutique manufacturer achieve better power density and integration than the world leader in EVs? Some will argue Koenigsegg's tech can't scale. But what if scale is no longer the only metric for success? If synthetic fuels become viable and regulations permit low-volume, carbon-neutral combustion cars, then Koenigsegg's approach becomes a blueprint for a parallel future. The provocative question is this: if Koenigsegg can build a four-seater that outruns hypercars, runs on carbon-neutral fuel, and has an electric motor that fits in a backpack, what is everyone else's excuse? Why are we told EVs must be heavy and that sustainability must come at the cost of excitement? Koenigsegg's announcement doesn't mark the end of electric cars, but it signals the end of their inevitability. The future is suddenly more open, more complex, and far more interesting. The next few years will reveal whether Tesla doubles down on its pure electric formula or is willing to learn from a small Swedish company that just rewrote the rules of performance. If they don't, the future of driving may just belong to the rebels. Thanks for watching. If you enjoyed this analysis, be sure to like, comment, and subscribe. Click the next video to see more.